All right, everyone, today we're going to be finding the greatest common factor of each pair of monomials. You can find it on page, I believe it's 421 in your book. They've gone over the first couple here, and I'm going to go over them with you so you get a good idea of what we're doing here. We have 63p and 84, and we're finding the greatest common factor. We break down 63p. Well, what goes into 63? It ends in 3, and it has a 6 in it. So I know 3 goes into both 6 and 3, so I'm going to divide it by 3 first. Well, 63 divided by 3 gives me 21, and I know 7 times 3 gives me 21. So I'll also factor 3 and 7, and then, of course, I have the p left over. I can't break it down any more than that, so now I've got to go to the 84. 84, it ends in 4, so I know it's divisible by 2, but half of 84 is 42, so I can divide that by 2 as well. 42 divided by 2 is going to be 21, and that gives me 3 and 7 again. Now, as you can see, they circled 3 and 7, letting you know that both of them are factored, okay? I have a common factor in both 63 and 84. 84 doesn't have p, so it's not factored in. These numbers then are not factored. So now I can take 3 times 7, and that makes 21. So my greatest common factor for 63 and 84 is 21. All right? We'll do one more example here with number 19. Number 19 says we've got 30 RS and 42 RS. Well, as you can imagine, we're going to do it again. 30 RS can be broken down into dividing 30 by 2, which gives me 15, and 15 can be divided by 3 and 5. So we have 2, 3, 5, and then R and S make up 30. And when we break down 42, of course, that's divisible by 2, which gives us 21, which gives us 3 times 7 make 21, and the RS is there. And again, you see the common things that they have. Both of them have a 2 that was factored. Both of them have a 3 that was factored. Both of them have an R and an S that was factored. So this tells me 3 times 2 is 6. 6 RS will be my greatest common factor of 30 and 42. All right, it's time to go ahead and work R's. I'm going to do number 21 here. 21 has 40 and 60. Well, if I did 40x, I know that 40x is divisible by 2, which gives me 20. And 20 can be divisible by 2, which gives me 10. And 10 can be divisible by 2, which leaves me 5. So I know that 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40, and then we have that x left over, so it'll be times x. Next is 60. If I take 60x, I know it's divisible by 2, which gives me 30. Well, 30 is divisible by 2, which gives me 15, and 15 is divisible by 3 times 5. And then all that multiplied by 10. Now let's find the things we have in common. I'm going to highlight them here. And we see that 2's are both in 4 and 6, and 5, and x. And now we simply go ahead and put them together. Well, 5 times 2 is 10, 10 times 2 is 20, and then there's x. So the greatest common factor of 40 and 60, 40x and 60x equals 20x. All right, let's go to number 23. 23, we've got 100xy and 75xyz. Well, 100xy and 75xyz. Well, 100 can be divisible by 2, which gives me 50. 50 is divisible by 5 and 10, so I could put 5 here, And 10 is divisible by 5 and 2. So 2 times 5 is 10, 10 times 5 is 50, 50 times 2 is 100. And then we have x and y. Next, we got 75 xyz. Well, 75 is divisible by 5, which gives me, let's see, it's going to divisible by 5, that's going to give me, goes into once and leaves 2, so it's 15. And that's going to be divisible by 5 and 3. So 75, that's 5 times 5 is 25, and 25 times 3 is 75. And then we're going to multiply that by x and y and z. So the greatest common factor is going to be, well, it's highlighted again, so we've got a good idea of what we're doing here. I see that there's 5 in both of these, and there's 5 in both of these again. There are no 2's down here, but there is an x, there's a y. So I can go ahead and say that 5 times 5 is 25, and then xy, 25 xy. And some of these are really easy to see. If you could see this, we know that 25 goes into 75 and 100, and we know that there's an x and a y in each of these. So that was kind of an easy one. Let's go to number 25. Factor each expression. If the expression cannot be factored, right cannot be factored. Well, can this be factored? What goes into 18 and 6? Well, 6 goes into 18. So we know that 6 is the greatest common factor. And when we would multiply that, well, what times 6 gives me 18? 3. So what gives me 18x? 3x. And then what times 6 gives me 6? Well, that's going to be plus 1. So if I factor this, 6 times 3x will give me 18x, and 6 times 1 will give me 6. And that is my expression factored. Let's go to number 27. We got 10x minus 35. Well, we both know that 5 goes into 10 and 35. So we can say that 5, and if we did it the way the book tells us to, we could say 10x here. What goes into 10x? Well, that would be 2 times 5 times x. See, just like we did up here. And then what would go into negative 35? Well, that's going to give us 7. We'll just say negative 7 times 5, and there's nothing else. So what's in common here? My 5's, right? And that's what we set up here, 5. There is no x. So what times 5 will give me 10x? 2x. And what times 5 will give me negative 35? Look over here how the answers are all given to us. 2x, right? And then what gives us negative 35? Negative 7. That's it. We'll do number 29 again next. As we can see, 29 has 30x and a negative 40. Well, what goes into 30x? Well, I would say 3 times 10. And what goes into 10? Well, we could say 5 times 2. And then, of course, we're multiplying x. Let's double check. 5 times 2 is 10, times 3 is 30. So what goes into negative 40? Well, we can say that we've got negative 2 times 20 will give us that. And then what makes up 20? Well, 2 times 5 times 2, right? Let's double check. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is negative 2 is negative 40. Let's see the things we've got in common. Well, I see we've got 2's in both of these. And we got 5's in both of these. And there's really nothing else. So that gives us 10. So we can say that 10 is the greatest common factor. 10 times what gives me 30x? Remember the answer's up the top, 3x. And 10 times what gives us negative 40? Well, negative 2 times 2 is negative 4. All right, let's go ahead and head down to number 31. A square scrapbooking page has a perimeter of 8x plus 20 inches. What is the... Okay, so next we say a square scrapbooking page has a perimeter of 8x plus 20 inches. What is the length of one side of the scrapbooking page? All right, so one side, a square scrapbooking page. So we know that 8x and 20 are both divisible by 4. And since they're saying it's a square scrapbooking page, has that perimeter, what is the length of one side of it, right? We're going to have to divide that by 4. So 4 will be our greatest common factor. 4 goes into 8x 2x times. And how many times 4 go into 20? Well, 5. So 4 times 2x will give us 8x, and 4 times 5 will give us positive 20. And that will be our answer. Let's go to number 33. Write an expression in factored form that is equivalent to the given expression. Show your work. All right, we want something in factored form that is equivalent to this. All right, if we were to do this, let's check out number 23. First of all, well, we want to go ahead and say what is going to go ahead and give us 2/3 x. 2/3 x. Well, first we remember that we want to put 2/3 in front. And now we've got to figure out what's going to go in the middle. We know 2/3 times x will give us 2/3 x. But now we got to figure out what times 2/3 will give us 6. We can figure this out by using division, because if we're multiplying this to get 6, we can say then that 6 divided by 2/3 will give us our answer. If you think about this, this is using our KFC again. And if I keep the top number, that's going to be 6/1. And I multiply and I flip my bottom number, 3/2. That gives me 18 divided by 2. 6 times 3 is 18. 1 times 2 is 2. Every fraction is really a division problem. 18 divided by 2 gives me 9. So let's see if that works. Well, if I take 2/3 of 9, well, that's 9 times 2, which is 18, divided by 3. That gives me 6. Perfect. So our expression that is equivalent will be 2/3 times x plus 9. All right, let's do number 35. Once again, we're going to put our fraction in front, 5/6. We know that 5/6 times x will give us 5/6x. Now we've got to use our KFC method again. We can't go ahead and just remember we're going to multiply the bottom number to our number and then divide by our top number, because it's going to give us the same thing. Watch. We're going to take 6 times 30, which will give us 180. 180 divided by 5 will give us our answer. Let's see if that works out when I do KFC again. Remember, we've got negative 30 all over 5/6. If I were to do this, I see that I have negative 30 over 1 times 6/5. Isn't that what we said we're going to do? Absolutely. So this is going to give us 180, negative 180 to be exact, all over 5. And if we were to use our calculators, even if we did long division, let's just practice some long division here. 180 divided by 5. Well, that's going to give us 3 for 15. And that gives us 30 left over. And that's going to be 6. So our answer would be 36. And since it's a negative number, we know that's going to be at negative 36. And let's see if that's true, shall we? 5 times 36 divided by 6. Okay. I'll use my calculator this time. 5 times 36 divided by 6 gives us 30, and that's what we wanted. All right, last one, we're going to do the number 37. 37 says I've got 8x plus 18. So we'll take 3/8, put it in front. We're going to multiply it by x. And we're going to add it to, well, let's see, 8 times 18 divided by 3. (18) times 8 divided by 3 will give us 48. So our answer is 3/8 times x plus 48. Should we check it? I know some of you are thinking that would really work out with the KFC, Mr. Mendez. All right, let's give it a shot. If I were to do this, I would be saying that I had 18 over 1. And I'm using my KFC method. I'll be multiplying it to 8 over 3. And what we did, 18 times 8 divided by 3. We could also use our ruling out method and make that a 6, right? And 6 times 8 equals 48. And look at that. That gave us our answer. All right, that's it for today. Good luck on your homework, and see you in class.